So this set of data is a little harder to analyze. If you take a peek at the data and you insert a chart, you might notice that it's curving upwards. So your first guess might be to think that y is proportional to x squared. But it doesn't go through 0, 0, and because every 12 notes the frequency doubles, this function keeps doubling. It's an exponential function. So finding the math model for an exponential function is not a tool we have, so I'm going to show you a way that you can do it using Desmos. So what I'm going to do is I'm going to copy the data. So this first column right here is x, and the second column is y. So I'm going to copy the data, I'm not including the titles, okay? So just the data. And you might notice my data is different than yours. I'm using a different set of data. It is incorrect, but I'm using it so that you don't just copy my answer. All right, so once you've copied the data, you're going to go to a new window for Desmos. And over here, if you simply paste that data, it'll put it into a column for x and for y. And it'll plot the data over here, okay? So now what we are going to do is we are going to try to find an exponential function of this form. Y equals a times 2 to the power of bx. Okay? And we're going to try to figure out what a and b are so that we can make this fit. Now, I'm not going to add a slider. What I'm going to do is type in values here. So you could try starting with maybe 100. And b, let's start with 0.1, let's say. So here is the graph showing the math model right here. And we want to tweak this value right here, this 100, and this value right here. We're using 2 as the base of our exponential function because an octave is a doubling of frequency. So every time you go up an octave, you have twice the frequency of the previous octave. So that's why we're using a base of 2 in our function. So what you're going to do is you're just going to tweak these. So here's 100, there's 200. You may notice some things about this graph where it crosses the y-axis. So I'm just going to keep tweaking this. If I get to 320, it goes right through that point there. So that's good. And now I want to tweak this, 0.1. I'll make it 0.2, and so it bends too much. So I'll go to 0.1 and maybe 5, and it still doesn't quite fit. So 1.4, so you just kind of guess and check. 1.4 is still not quite fitting here. So 1.3, it's getting pretty darn close. 1.2 is not enough, so it's got to be between 1.2 and 1.3. So let's go 1.25, and there we go. In this case, I've got it. So I have a math model. I've found it by guessing and checking. It is of the form y, which is the frequency, equals this constant times 2 to the power of 0.125 times x. Now, your model is not going to be this. You're going to have a different number here, not 320. You're going to have a different number here, not 0.125. But that gives you a place to start, and then you can tweak them until your math model, this equation right here, your math model, fits the data, which you'll be able to see. And then you're going to take a screenshot of this entire screen. I want to see the data table, I want to see this math model, and I want to see the fit on the graph. If you happen to mess with the zoom so you can't see it anymore, all you got to do is click this little, on the bottom of the table, this little plus, and it'll zoom back to the data table, okay? And that's what you're going to do to find the math model.